Huh?
Yes, sir.
Yes.
Yes, sir.
Okay, fine. Okay, so now there is a shorthand, so some notation. This transition, right? Probability of, for example, xn equal to in. So some, I'll make this little easy. So let me not write it like this. I given xn minus 1 equal to j, I'll use a shorthand for this. Okay, so this is from, okay, I'll just exchange this. Okay, I'll call this as j and I'll call this as I. I'll write this as p I j of n. Okay, why pij of n? Because, for example, when you looked at this Markov chain, right? This particular Markov chain, you used a coin. The bias of the coin was fixed at p. Okay, but what if I use different coin as in time progresses? That means I'll have different biases. Then the transition probabilities, these are called transition probability. Okay, this is called transition probability. Okay, this transition probability will change over time. It's possible to construct such a Markov chain, or it's possible that there are Markov chains with this kind of change in the probabilities. Is this fine?
Hello, sir.
Yes.
That this probability is same as probability of yn equal to plus 1, right?
Which yn? The example.
No, no. In this yn is this
There is
tossing.
no yn here, right?
No,
There is xn.
I'm defining it as tossing of it, random variable.
Huh?
Tossing of coin, related to tossing of coin.
Tossing of a coin is an IID process, right? It's a trivial Markov chain. Nobody wants to. I mean,
No, sir. This is
huh.
same as getting head on when we are standing at x minus ith position.
No, it depends on what J and I is, right? So it's not just head.
Okay, okay, fine.
It can go to multiple. You can probably throw a dice also, right? Depending on the outcome of the dice, you have two dice. Let's say one is marked 1, 2, 3, 4, 5, 6. The other one is marked as -1, -2, -3, -4, -5, -6. You pick one of them randomly and throw whatever outcomes you get. Whatever outcome you get, you will just move by that distance. If it is a +2, you'll move +2. If it is -5, you move back to the left by -5. Something like that. Okay.
Yes, sir.
Okay. If Pij is of n is independent of n, and then we say that the chain is a homogeneous Markov chain. Okay, so that means I'm going to use the same dice or the same coin over time. I'm not going to change it. So the transition probabilities remain the same irrespective of what n is. Then we say that it's a homogeneous Markov chain. Is that fine? Okay. Huh. Okay, so now let's look at a few other things. So I'm going to construct a matrix out of it. So let me call this as P.
Hello, sir.
P. Yes.
Sir,
Yes.
here n is the time instance, right?
You can think of it as time or whatever you want to. So not just time, right? So you can be looking at examples where n need not necessarily represent time. It can represent some index or something like that, right? So for concreteness, you can assume n to be time slot.
Sir,
Yes.
so you just mentioned in the definition that it is a Markov chain if it depends upon the previous immediate previous position. No, sir.
It
But
only depends
in
on, yes.
yeah, but here you are saying that it is independent of n. So how could it be independent of n? Because it always depends just previous situation. No, so like
Previous it
if
depends, but it doesn't depend on at what time you are looking at, right? What is this probability? This probability in minus 1, right?
yes,
So
sir,
for
yeah,
example, in is 2, in minus 1 is
three. Suppose
1,
one,
right?
one,
Huh.
yeah.
So what is in minus 1? So probability of
Okay.
xn equal to 1 is what? P,
P.
right? So this
Yes,
probability
sir.
will be P, right? So on the other
Yeah.
hand, so it doesn't matter, right? So if in plus 1 equal to 2 and in equal to 1, and you are looking at probability of xn plus 1 equal to in plus 1 minus in, still it's P, right? Doesn't matter at what
Oh,
time you are looking at the transition, right?
okay, sir. Okay.
Okay. I'm using the same coin all the time. That's what it says. So how
Okay.
many rows should be there here? Any idea? Okay. Just to be consistent, I'll just see what the book uses. He uses M. Okay. So I'll assume that there are M states. So basically, the cardinality of S is M. Okay, that's what I'm assuming. So this will be P21, P22, etc. P2M, and
Hello,
so
sir.
on. PM, yes.
So some of these elements of these rows should be zero, right? I mean, it cannot go to every state from one state.
It can go to any state from one state, right? We will see that. Okay.
Okay, okay.
We will study that in detail now. So this is a matrix which describes the transition, right, from one state to another state. For example, if you are looking at a transition from ith state to jth state, it's P
Hello, sir.
J I, right? Yes.
The sum of the rows should be equal to 1, right? Sum of the rows are the columns.
Can you tell me which one is true? Okay, I haven't. So what is P12? You are starting a state 2 and you are going to state 1. That's what it says.
Probability of going from any state to state 1 is 1.
Hmm?
Total probability.
No, probability that you start at a state, let's say I, going to some state out of that or in any state, right? It could even remain, should be 1, right? If something should happen if you are in state I, you should either remain in state I or you should go out of state I, right? The probability of something to happen given that you are in state I is 1. That is nothing but what?
Columns.
Columns are one.
Clearly. So if you look at, for example, Pij, you are in state J and you are going to state I. So summed over all I should be 1. Okay. This is clear?
Sir, can you use the notation PJI? I mean,
Hmm?
sir, I mean, can
Did
you
I
use the?
use?
Yes, sir. Use JI.
Okay. So no. It's, see, this is Ij. That means,
Okay.
the 1 second. Let me just verify this just to be consistent with the book. So Ij is from I to J. Okay. Ij is from I to J. This is correct. You start at I and go to J. This is Pij. Okay. You start at I and go to J. This is Pij. So you're starting at I. Okay. So this is correct. So Pij, right? From all J. So you start at I and you go to some state J, is the sum is 1. Is that clear? Why is that? It's basically, if you are going to state 2, you look at two events. You are going from I to state 1 and I to state 2. If you look at these two events, these two are disjoint, right? Because if you go to state 1, you cannot go to state 2. So these are disjoint events. But if you look at going from state I to some state J and you exhaust all possible state J, that will give me the entire set omega, right? The sample space. So probability of union of these events given that you are in state I should be 1. But since this is disjoint, you can write it as sum. Okay. I'll leave this as a homework for you to get, convince yourself that this is true. Everyone, this is fine, right?
Yes, sir. Sir, one more thing.
Yes.
Is this matrix P
Hmm.
a symmetric matrix?
Okay, can you think of whether it's symmetric or not?
Sir, I'm saying this because, sir, the probability from going from I to J, like from 1 to 2, and will be same, might be same
Not,
for 2
It's
to
not,
not
3.
symmetrical.
not necessarily, right?
P1 minus P.
Hmm? No, not necessarily, right? Okay, before that, this matrix P is called transition probability transition matrix. Okay, or transition probability, probability transition matrix, right? I think this should be probability transition matrix. Okay. So now coming back to your question, so I'll take a very simple Markov chain. So from now onwards, I'm going to write it in this fashion. Okay. So there are only two states, 0 to 1. Let's say there is a frog in the pond. It can either jump out of the pond or stay inside the pond. It's going to jump outside the pond with probability P1. Okay. With probability 1 minus P1, it will stay inside the pond. If it is outside the pond, it can go to jump into the back into the pond with probability P2, or it can stay back with probability 1 minus P2. This is a pictorial representation of the entire matrix. So how do you write this? Let's say 0 1 0 1. Okay. If you go by this, right, P1 P1 2, right, this is P0 0. What is the probability? 1 minus P1. This is P11. This is 1 minus P2. So what happens to this? 0 1. That means you are in state 0 and you are going to state 1, which is P1. This is P2. Okay. Fine.
So that means we can design it to be a symmetric, but it not necessarily be a
Not
symmetric.
necessarily symmetric.
Yeah.
Yes. Most of the times it need not be symmetric. Fine. Okay. Any questions? And needless to say, Pij is greater than or equal to 0 for all ij. Okay. This is also true, right? These are some of the properties that we can immediately infer from the probability transition matrix, right? Okay. Any questions so far? No?
So PIJs are the probabilities, no sir?
Yes. Pij's are
So
the
it should be 0 to 1 only, I think.
that is also given,
Yeah,
right? So
yes, sir.
these two put together will ensure that it's between 0 1,
Mhm.
right? Okay. So now let me ask you one other question. So probability, okay, that you are in let's say n plus 2. Let me just write it like this. Okay. Okay. So after n step, you are in state j. Okay. I'll just go back. Ij is ij. Okay, I to j. Okay, fine. So you are in state, let's say n minus 2 is I. How do you compute this? You understood what this says, right? N minus 2, that is 2 steps back, you are in I. Now, what is the probability that you will be in state J after 2 steps? How do you write this? What is this? Can you compute this? Can you try?
Yes, sir. You can write xn is equal to z condition on xn minus 1 and product xn minus 1 is condition on xn minus 2.
Okay, good. That's enough? That's enough? Huh? Okay, so let's take a very systematic approach. So what is this? I can xn equal to j is an event. I can intersect with the entire omega, right? Nothing will change. Do you agree?
Yes, sir. Yeah.
So I'll intersect with xn equal to j. Okay, xn minus 1 equal to k, given xn minus 2 equal to I. But xn minus 1 equal to k is just one event. It's not the entire omega. If you sum it, essentially I have to take the union over all k. Okay, then I'll get the entire omega. Since these are all disjoint event, union becomes the sum. Is this fine? This is clear? Fine?
Sir, I just one doubt. Sir, in this general case, I mean general Markov chain, I mean from in every state there is a probability of going to every other state.
Not
And
necessarily. Not necessarily.
then sir, some of the case should be redundant, right?
Meaning?
Sir, this probability of xn equal to j, comma xn minus 1 equal to k.
Huh?
So there may be some states from that we cannot go to the jth position or jth state.
Then that will be 0. That's all. So I can always write this, right? There is nothing wrong in writing this. The
Ah,
probabilities could be 0. Then I'll be counting 0 for towards that. That's all.
okay, okay.
Okay. So now I can write this. This is clear, right, everyone? This I can write probability of AB given C is probability of A given BC into probability of B given C, right? Given xn minus 1 equal to K, xn minus 2 equal to I times probability of xn minus 1 equal to K given xn minus 2 equal to I. Okay. Now let's look at this summation over all K. What can I say about this? Xn equal to J given xn minus 1 equal to K and xn minus 2 equal to I. Well, it's independent of the past, right? It only depends on
xn minus 1.
1 equal to K. And this is what P, well, now it's a homogeneous Markov chain. This transition from I to K does not depend on N, right? The time step. So it should from I to K. Okay. What is this? This is summation over all K. The first term is, I don't know, there's some issue with the, got stuck.
Sir, okay.
Hey, just sorry, man. So I'll just, hope, okay, good. Oh my God. I'll quickly, can I directly write this? Is that okay?
Yes, sir. Yeah.
So this is what? Summation over all K. The first one will be, I go from K to J, K to J, and then the second one will be I to K. Is that fine? Let me just check I get confused with the notation. So I to J is I to J. Okay. I to J is IJ. So K to J, that's correct. So K to J and I to K and K to J. Okay. Is this fine? Okay.
Yes, sir.
So
Yeah.
what is this? So this is the probability that you start at I and go to J in 2 steps. Okay. I'll write this as follows. Okay. I start at I, go to J in 2 step. Okay. This is the notation. So essentially I start at I, go to J in 2 step is summation over all K. I start at J, go to K, and then from K I go to I. Sorry, the other way, right? I start at I, go to K, intermediate state. From K I go to J. I take all the intermediate. So pictorially it's like this, right? So I start at I, go to some state K, right? Some whatever state it may be. It could even be I itself, okay? And then I go to state J, okay? So if you sum over all possible intermediate state, that gives you this. Can somebody tell me based on your linear algebra, simple algebra, right? What does this corresponds to in terms of matrix?
It's inner product of ith row on jth column.
Correct. So what does that corresponds to?
Sir,
Covariance.
Oh my God, what is covariance, man? These are probabilities, right? You take p squared, you take the matrix P, take p squared,
multiply with itself.
and look at the ijth element of it, right? You take p square matrix, consider, look at the ijth entry of it, that will be pij2. Fine. Okay. Now let's look at what might happen if I were to write or if I were to get pijn. What do you think is the answer? Any idea?
Should be p
Yes, sir. There
power.
will be n steps like summation over k.
P power n ij,
Yeah,
right?
in terms of
This
matrix.
is
Yes, sir.
guess. Okay. This is something that we can guess easily, right?
Yes, sir. Yes, sir.
But now, how do you prove this? Any idea?
Similarly, such as above we have done.
No, you come from math background, right? So what is it that you will do if you want to prove this kind of a general statement?
Induction.
Induction,
Induction,
sir. That's
right? So you have to do induction. So I'll leave this as an exercise. Okay, use induction to prove this. Okay. So this result is called Kolmogorov-Chapman equation. So I'll not. What happened?